Now it's hard to improve perfection, but you may have wanted to adjust it, and in this video I'll go over 2 adjustments I made to my 2004 Polo 9N. The first thing I wanted was a more convenient way to use the car. The original key is cool and has a little light, but requires you to physically access the lock cylinder and use your hands to turn the key. I'd much rather press a button from 20 meters away. Secondly, for those long drives, I'd rather the car keep the speed than me modulate the gas pedal. So in this video, I'll go over 2 upgrades, specifically the cruise control installation and remote central locking upgrade. I'll cover my car's specifications and hardware, including the costs and the full installation process, including wiring. As far as I can tell, this is the most OEM-like installation process you'll get. Lastly, take everything you hear from me with a grain of salt. I'm not a mechanic, I don't know what I'm doing. I'm just sharing with you about a week's worth of tinkering at night with my car and the results. In my opinion, any 2002 model Polo or 9N model can have this upgrade based on the information I gather from VW's self-study program, or what I call SSPs. According to VW, these explain the design and function of new developments. The Polo 9N has 2 dedicated SSPs, and these detail the exact upgrades I want to do. SSP 265 discusses the Polo's electrical system or CAN databus system. In this system, everything's connected to module J519, which is the electrical system control unit, and one of the functions of the control unit is the cruise control system. SSP 265 also discusses the car's convenience system, which is controlled by module J393, the convenience system control unit. Here, the use of a remote key is discussed. Lastly, the program also provides a wiring schematic of the electrical system control unit, and again mentions the cruise control system. Here, the cruise control switch is connected to the engine control unit, and that's denoted as J. So to close, I believe that if your car has the correct components or modules installed, all of these systems should work, and this gets us to our next topic, which is compatibility. Here's an example of a J519 module, and on the module you'll find part numbers. According to rostech.com, only modules whose part numbers start with 6Q0 or 6Q1 are cruise control compatible. Next, here's an example of a J393 convenience module, and as far as I can tell, this must have part number 6Q0959433E. Lastly, we have the ECU, and according to rostech.com, this can't be a CMOS 3PD module, but generally I didn't find much information on ECU compatibility. So at this point, you should understand the general theory here and what modules your car might need, and now we can take a look at my car and my car's hardware and see what I needed. Starting with the general specifications, I have a 2004 Polo 9N with a 1.2 liter 12V motor producing 64 horsepower. It is a 5-speed manual, and if you want more information, I recommend you check out my last video where I cover this in more detail. For the modules, you'll find the J519 module under the dashboard on the left side of the driver's footwell above the pedals. The module is right behind the OBD2 connector. For the J393 convenience module, look to the right of the J519 module and you'll find a few vents for the air circulation, which is held in by a Torx T20 screw. I recommend removing the screw, pulling the vent out, and then you'll find the convenience module behind it. This module is possible to access without removing the vent, but I think it's a real pain in the ass. I didn't even bother trying because it's so easy to remove the vent, and it's kind of tucked up above the gas pedal, really against the center console area. For the engine ECU, it's accessible right under the hood. My J519 module was a 6Q1 module, and therefore I didn't need to replace it. My J393 was a 6Q0959433G, and therefore I did need to replace it. And for my ECU, I don't have a picture of it, but here is the sticker from it, and this was a 03E906033L CMOS 3PE module, and I just assumed this would work. So now I just want to get into the hardware that I needed before starting the project. So I went ahead and ordered a few components, and first of all I would need new stalks. So from my research, these are part number 6Q0953513G. These are shared between the VW Polo 9N and, at least in addition, the VW T5 transporter. So I ordered a pair and a wiring lube for a T5 transporter, and I paid 104.74 euro. In addition to new stalks, I would also need a remote key. This has original part number 1J0959753DA, and I bought this off eBay for 20 euros and 20 cents. Next, as we identified my convenience module isn't suitable, so I picked one up off eBay, and this was a 6Q0595433E. H01 or S0001 model. I don't know what car this was from, but I paid 45.98 euro. So in general, these were the three components I needed, and the only hardware I needed actually to complete this whole project. I did spend more money, and I'll kind of cover the total cost at the end of this video, but these were the primary components I needed. So anyway, I think this is enough background info, and let's get into the project. So in general here, a lot of what needs to change is going to be behind the dash. So there's obviously going to be cables from the stalk, which will eventually have cruise control. These need to run through the steering column and then into the dashboard. There's some plugs up in the upper dash that need to be connected, also the fuse box, and then a module down below. So in general, it's going to help to take the dashboard out and also take these seats out. Since I'll be working with the car's electrical system, I start by disconnecting the battery. As a disclaimer, I decided to remove my whole dashboard for this installation, but I've seen forums online where people do this from the footwell alone. I think removing the dashboard is pretty easy and allows you to wire everything correctly, so that's the way I opted for. As there's plenty of information out there on disassembly, I'm going to montage most of this, but I'll put annotations where important. Out. Attached to the stalks is your airbag slip ring, and this connects to your steering wheel airbag. This ring can rotate about 2.5 turns to the left and right of center position, but after that it'll tear the ribbon cable inside it. So you should really tape this ring up to prevent it from rotating after disassembly. And that's literally how. So starting off here, we have our T41 connector. This is where our cruise control is going to plug in, and then the wire loom runs down along here and up into the body of the car. And so by having full exposure here, we can access and run our wires in parallel. And this is going to be eventually heading down to this control unit. Just to give more context to the T41 connector, this is the connector that plugs into your stalks. And the new stalks have additional functions on the stalk arms, and this translates to more pins on the back of the component. So to accept this additional logic, the T41 needs additional receiving wires to connect the new stalks to the J519 control unit or the engine ECU. With the dashboard completely disassembled, we can now do all the wiring. This will vary depending on whether you bought a loom or you decide to make your own, so I'm just going to share with you my experience and wiring. Also, I never got my hands on an official wire loom or the electrical diagram for the wiring, but nonetheless, I made a few diagrams to show you exactly what I did with my system. First of all, looking back at SSP265, the program discusses the function of a compact connector that allows connections from the cabin to the engine bay. The compact connector is located at the top of the dash, sort of behind the speedometer. One of the connectors is responsible for the cruise control system, which is specifically connector D. SSP265 also discusses the fuse box, and on the Polo 9N, fuse 4 is responsible for, among other things, power supply to the cruise control switch. Now, this brings us to our wiring diagram. Starting from the bottom left, I have a depiction of the T41 connector, with pins 26 to 31 detailed. These are the pins we need to install in order to plug in our new stalks. All the pins, apart from pin 28, connect to the J519 control unit, and they plug into the XS3 port on the unit in positions 2, 3, 5, and 6. Pin 28 connects to fuse number 4. The wiring of pins 26 and 29 are a bit special. Both are connected to both the control unit J519 and connector D of the compact connector, which here is described as the T11A connector. Pin 31 connection to the control module also has an integrated diode. Now, I won't really explain the wiring loom in detail. This details nothing new from the previous diagram, but does identify all the relevant components in case you want to make this yourself. And all the dimensions above are accurate to the wiring loom I installed. Before I started with any of the wiring process, I first removed anything that might get in the way. So I took off the fuse box cover and then removed completely the J519 control module. As we know, the J393 convenience module will also need replacing. This won't really get in the way of the wiring, but I also removed it now. And then the compact connector module, which is located here in the dash, needs to be accessed so we can plug in the wire to the connector D. And to help do this, I went ahead and removed the air vent. Be careful, they kind of fly. So now we get to the wiring loom, and as I mentioned in the hardware section, I bought the stalk and wire loom set from a T5 transporter, which needs to be modified if you want to use it in a Polo 9N. So the first thing I did was I got a voltmeter and I tested the conductivity between the T41 input pins and the outputs. So the first issue I found was that the XS3 connector didn't have the right inputs. Pin 31 was connected into position 4 and pin 27 to position 5, and instead I needed pin 31 in position 5 and pin 27 in position 2. So I ended up correcting this by just pulling the pins out of the connector and then reinserting them in the right position. Another issue around this connector was that pin 31 going into connection 5 was missing a diode. So I fixed this by cutting back the insulating tape and exposing more wiring, and then cutting the wire and exposing the copper filaments. It was kind of a pain to film this, so I ended up just taking photos, but the first thing I did was I physically wired the diode to the copper filaments before applying flux to both ends and soldering both ends of the connection. Then on each of the solder joints, I applied some Vaseline, and then I double heat shrinked each connection, and then I went ahead and heat shrinked the whole connection, including the diode. After that, I just reapplied insulating tape over the loom to kind of bring the loom back to its original state. So the last issue with the wiring loom in general was the connection, or kind of the crimp connector that was supposed to go into the T11A connector module in the compact connector. So when I pulled the connector out, I could see that all the other plugs there had kind of male connectors, and they were going into female connectors on the engine side of the compact connector module. I first double checked that my car had a receiving contact on the opposite side of pin 10 of the T11A connector, which it did. So I went to my local VW dealer, who gave me a few free repair wires, and I ended up soldering one of these in. Again, I applied Vaseline to the solder joint and then triple heat shrinked the joint. So the last part of the wiring loom is the connection to the fuse box, and you can address this connection in a number of ways. You can kind of buy these fuse connectors or fuse bypass connectors, which will end up sticking out at the front of the fuse box, but I wanted a more clean look and decided to solder it in, and because of that, I won't do this at this stage, and I'll first install the rest of the wiring loom and then do the fuse box soldering last. To get started, I removed the cover of the T41 connector. First, you'll need to break a zip tie at the base of the connector, and after that, you can pull it apart. Now, you'll be able to see all of the connecting points in the connector housing, which are numbered. For the CCS wire loom, you'll want to find and populate connections 26 through 31. I wanted to run the loom from the dash through the steering column to the T41 connector. This would ensure the loom runs correctly alongside all the existing wiring, and would give me an idea of how much extra wiring length I had to play with once the pins were installed. Going from the dash, you'll find the wiring is held in by numerous housings and zip ties, which I would either remove or break, and then lightly secure the loom in place along the way.
We can keep this quite loose. We can bring all of these.
The wire loom I purchased had numbered cable sleeves, so once I got to the T41 connector, all I needed to do was identify each cable and then plug the crimp into the right slot of the connector. Afterwards, I took care to apply insulating tape where I could and replace the cover and zip ties that I had broken. I followed the same approach going back along the steering column using zip ties and insulating tape. My goal here was to keep the wiring as clean as possible. I then ran the ECU wire up to the compact connector. To insert the crimp into the T11A connector, be sure to pull down the purple plate at the bottom of the connector. After that, the crimp will slide right in, and here is a little comparison of a before and after. Now for the fuse box wiring, this wasn't filmed very well, but I'll try and summarize it here. So what I wanted to do was run my cruise control cable after fuse 4, and to do this I decided to completely cut the outlet cable from the fuse box and then solder in my connection. On the left you'll see the original outlet from the fuse box, and then in the center the continuation of that outlet from fuse 4. This is the original wire. Next, on the right, you can see the wire coming down from the cruise control system, which has the blue casing, and here's an explanation that I gave at the time.
So these would normally be connected, and then we have the wire coming out of our pin, whatever the fuck, 31 or whatever, or 28. This is a black pin 28 coming from the T41 connector. So what I've done is I've essentially cut the wire here. These two will be joined together, and then from here they're going to connect back up to pin 4, and for this I need a wire.
I don't think I can really explain better than that. Anyway, here I start prepping the ends of the wires. I then prepared a bit of extra cabling to join everything together, and then, as before, I applied flux to all the joints, I soldered them, applied Vaseline, and then I triple heat shrinked each connection. I finished by cleaning up the wiring after the fuse box with some insulating tape, replacing a few zip ties, and putting the cover back on. As a final wiring check, I checked the resistance through the Loom. What I wanted to do was firstly ensure that the wiring was correct as per the wiring diagram, and then check the resistance through all of the solder joints I made. I did this by cycling a male-to-male connector through the new pins on the T41 module, and then checking the resistance at the output with my voltmeter. As you can tell, the readings were a little bit jumpy, but I think the value sat around here. Now, I don't really know what any of this shit means, but what I do know is that the lines were fairly consistent apart from the cable which had the inline diode, so I assumed all was well. At this point, I completed the wiring by plugging back in the T11A connector, and once this is in, you should make sure you slide this lock at the bottom to make sure everything locks in place. Alright, so at this point we're fully done, and I just want to kind of show what's going on. So, primarily, we have the T41 connector. This thing is fully hooked up, and all the cables are routed through here in this wire loom. They're in this piece of plastic, so above the ignition cable, and they route up through this plastic housing and into the dash. Once they come out of this plastic housing, they end up right here. This is the wire I'm pushing, and one part goes down. It goes behind the relays on this larger wire loom up here, and then comes out towards the fuse box. So actually, through this wire loom, there's some cables that go into the fuse box, and then here is the other connector. Down below it is this one right here, this little guy, and he's wire loomed in with all the rest. And then the other part. Unfortunately, that's the only video I had of the cabling, and that's all I can share on the end result. At this point, I started putting everything back together, and honestly, I didn't film most of it. During the reinstall, I used thread locker where applicable, which was standard on the steering wheel bolt and the bolts that hold the seat rails down, and then I fixed any broken zip ties, loose cabling, and foam trim. After I reinstalled the full dash, which I did off camera, we pick up here with the dashboard mostly reassembled, but the stocks haven't yet gone in, and that's the next step. At this point, I also had the J519 module back in place and fully connected. So first things first, I connected the new stalks to the steering column. Now, be careful here to allow the pull tab at the back of the connector to drop down, or the connector and the stalks simply won't connect. Next, you need to attach the airbag slip ring, and I just want to give a little disclaimer here on how to separate the slip ring from the old stocks, and I gave a little explanation at the time, so here you go. Now, while trying to bring over my steering fucking stupid ass ring here, when I try to take it off this, what I realized was that I fucked up and I tore the fucking end of the cable off. And the reason I did it is because this connector cannot be removed from this housing. And this piece, you will think, oh fuck, I need to push that down. It doesn't fucking push down. It's solid plastic and you can't actually remove it by pushing on it down. But let me show you how it actually comes out. What I recommend doing is you take a flathead screwdriver and you kind of just run it along the top of these pins down through here. And what you're essentially going to want to do is find your way towards that piece. So
something like this. And there you go.
And now with that out of the way, you can attach your slip ring safely. And in my case, I had to buy a replacement.
So here we are finally done, and the car is back together. Seats are back in, dash is back together, the controls are back together, and we now have our stock. What I'm gonna do first is connect the battery, turn the car on, and take it for a drive with the old key. I'm not gonna fuck with the transponder, I'm just gonna see if everything still works correctly.
So at this stage, I reconnected the battery and started the car using my old key. What you just heard there were my locks triggering 3 times as I put the key in the ignition. After this, the car turned on normally with all the expected lights on the dash. Bear in mind at this point I had the new J393 or convenience module installed. With the car starting normally, this told me that everything was okay with the wiring after fuse 4 because, among other things, fuse 4 is responsible for the fuel pump. I then tested the stalk's basic functionality and everything was working, including the lock switch on the driver's side door. When I turn the car off, you'll notice my locks activate again. This is due to the programming of my replacement J393 module, which I wasn't used to. After this, I went for a test drive to try cruise control on the highway, and unfortunately, nothing worked. At this stage, I tried to turn on the system multiple times using the stalk, and no light came on the dash and no speed control took effect. The CCS system was completely unresponsive. In order to get the CCS working, I'd need to activate it again with a diagnostic tool, so I went home and tried to pair my new key remote instead. So before pairing any new key with your car, you need to have the key cut so it works in the lock cylinders, but you'll also need to have the transponder in the key coded to work with your ignition system. Thankfully, I had a spare key, and this meant I had a working transponder in there. So all I had to do was go to my local key shop and have my key cut, and then I isolated the working transponder from my spare key. My spare key came apart real easy, and the transponder looks like a small glass ampule. Next, I opened the new key and removed the transponder that came with it, before inserting my old transponder and packing in a little foam on top to stop the transponder from rattling. You can find the method to pair the key online, but here's my first go at it.
No. Everything's locked. Ignition is on. Lock the driver's side door from the outside with the fob key. Press unlock with the remote and wait a couple of seconds. And press again. So, locking. I heard a noise. Let me lock. Unlock. Doesn't do shit. Now let me lock the car. Oh my fucking god. Unlock the car. It's working. Lock the car. Trunk.
So at this stage, you'll need some type of diagnostic software to get any further. I set up a pretty ghetto station and connected my computer to my car via the OBD2 connector. I launched VCDS and first ran a full scan of the car's modules. I wanted to look for any fault codes relating to the new cruise control install, wiring, or the convenience system module. The report didn't show anything that stood out to me apart from 6 fault codes related to the new J393 module or convenience module. The codes included errors that related to the rear left and rear right door, and as my car is a 2-door Polo, I assume, well, firstly, this came off a 4-door car, and that secondly, these were legacy fault codes. Next, I navigated to the engine module 01 engine and login-11 to enter the code 11463, and then I hit do it. This should activate your cruise control system. I then disconnected my diagnostic cable, I went for another drive, and I also used the new key for this drive to ensure that I didn't have any issues with it. So now we're in 4th gear. And we're going 40 kilometers an hour. Oh my fucking god. It fucking works. That's right. At this exact moment, 239 months, or almost 20 years after the car rolled off the production line, its cruise control system was activated with that little light in the dashboard turning on. I then went back to the highway to test the system a little more, and here's how it works. The toggle at the top is inconsequential to setting your speed. All it does is turn on the CCS system. If the system is on, the cruise control light appears on the dash, but this doesn't mean you set your speed, only indicates the system is active. You'll then need to use the toggles on the end of the stalk to control your speed. When you haven't yet set your speed, res or reset sets your speed to the previously used one, and set sets your speed to the current speed. Once your cruise control system has taken over, the rest toggle is then used as a plus toggle to increase your speed, and the set or minus toggle is used to decrease your speed. Then the system is disengaged if you press in your clutch, brake, or simply turn off the system. When I got home, I wanted to fix the annoying locking and unlocking that my car was doing. The convenience module I had installed would lock the car once it hit 15 kilometers an hour and unlock the car every time I pulled a key from the ignition. Also, the module was clearly designed or coded for a 5-door car and I have a 3-door car, so I wanted to fix that too. I reconnected the diagnostic tool and navigated to the J393 module and took note of the settings. I then also checked the fault codes, and this came back with the 6 fault codes related to the convenience module, but didn't show anything new related to the CCS system. I then reconnected my original convenience module and reviewed its settings. The main difference was the soft coding, being 00065 on the old module instead of 00067 on the new. The soft coding in these modules is usually indicative of something like how many doors your car has or its specs. So I swapped back out my old for the new module and updated it with my original's soft coding. After going into coding and updating the module soft code and workshop code to align with the original module, I went to adaption-10 and turned off auto locking and did the same for auto unlocking. At this point, I have the CCS system active and I've already configured my convenience module how I want it, so I cleared all the fault codes and disconnected the diagnostic cable. So now what I've done is I have recoded the module, but I didn't have to reconnect the key. The key was still remaining connected. The cruise control is activated and everything should be working. So I'm going to go take this for a drive, see how we get on. I'll rerun the fault codes at the end and see what happens. So without further ado. So after this next drive, I did rerun my codes and I essentially came up with nothing related to the CCS system and no new fault codes related to the J393 or convenience module. If you made it this far, thank you. I know it was a long video, but it was also a long project on my end too. About a week working at night in the garage and then another 2 weeks to get this video together. So I want to cover costs real quick. And these are the fixed cost of items that I think you 100% need to do this build. Here I broke it down into critical components and the cost per item and then the cost for shipping of each item. I think what you should take from here is that the cost of this project will vary depending on what's available to you and what type of deals you can find. The most expensive things for me was the key cutting, which was a service, and then the key, convenience module, and stocks. And I got all of those on eBay. So if you're able to source your components more cheaply, or maybe get them from a scrapyard or junkyard, this will definitely be less expensive for you. So the next cost I want to touch upon is kind of related to equipment and how you want to do this installation. So this is a DIY project. You can install this in many different ways, but you'll probably need access to torque heads or triple square torque heads, a soldering iron or crimp tools, and this will add to your cost. And in my case, I needed to buy a triple square torque head set, as well as wire trimmers, and then I broke my airbag slip ring, so I had to replace that too. And this added 73.11 euros to my total, and that brought it to 325 euros and 34 cents. But like in the first run, this cost will depend on what you have available to you. The last thing you'll need is a diagnostic tool to finalize your configuration, and if you are not able to get your hands on one, you'll probably need to visit a local mechanic, and this could also add to your cost. Anyway, that's all from me. Thank you once again, and I look forward to my next project.